Canada, a country containing 0.5% of the global population and 1/5 of the world's fresh water. So in a country that has more water per capita than anywhere else on Earth, how is it that a secure water supply still isn't guaranteed? The answer? Size. 60% of Canada's fresh water is in its northern regions, while the prairies of Saskatchewan, which border the US, are some of the least water-secure parts of the country. Facing challenges of expansive geography and changing climates, how are scientists using technology to ensure water resources are properly managed? Hi, I'm Stephanie Andrews,
climate scientist,
ocean adventurer, and systems specialist at NextSense. Buffalo Pound Lake supplies drinking water for approximately 25% of Saskatchewan's population. Although, if you saw one of the seasonal algal blooms that occur on the lake, you might find that hard to believe. It wasn't always like this. Buffalo Pound Lake was formed about 10,000 years ago by glacial melt. It's fed by the Qu'Appelle River, which was dammed twice in the 20th century in an attempt to control fluctuating water levels. A negative side effect of this, though, is excessive algal growth in the lake, which now essentially acts as a reservoir. A long-term partnership between the University of Saskatchewan and the Buffalo Pound Water Treatment Plant has supported real-time water quality monitoring of Buffalo Pound Lake. Dr. Helen Baulch is a professor at the School of Environment and Sustainability at the University of Saskatchewan and has been a key part of this partnership.
This is a key drinking water source. It's shallow with recurrent algal blooms and relatively high organic carbon. And those conditions create challenges for water management and for water treatment. The balance between flow from the upstream reservoir versus the local catchment has an impact on water quality, and climate variation also has a really important impact on water quality. So we're trying to understand that more deeply and hopefully help lake managers integrate water quality into their decision-making. One of the most important things we do is help the water treatment plant manage the day-to-day. They use sensors to help inform drinking water treatment. The partnership with the water treatment plant really emerged out of gaining benefit from the sensors we had deployed more than a decade ago now. It's evolved into a really deep partnership where we work to provide early warnings of challenging water quality conditions to help on water treatment, but also we all see value in understanding the lake itself more deeply.
Since 2014, researchers have deployed NextSense buoys on Buffalo Pound Lake, equipped with sensors to gather data in real time. These are used to understand differences in lake conditions near two water treatment intakes and how water quality changes as water transits through this lake. The fleet has expanded to comprise 4 buoys: Big Buoy, Super Buoy, and twins, Della and Sandy buoys. The buoys are equipped with temperature strings, wire-size sensors to measure phycocyanin, turbidity, pH, and oxygen, Lycor light sensors, an Li-190 placed in and above the water, and 2 Li-192s deployed under the water. The Super Buoy also has an exciting new technology, a CO2 sensor and a camera system.
We're looking for a variety of indicators that can help us better understand factors that can impact water treatment. Thinking about concerns spanning from blooms to understanding high wind events where we really rely on turbidity and our on-buoy met station. But we also want to understand the lake ecology, so things like metabolic changes and chemical changes. And the combined suite gives us some really interesting scientific opportunities to understand blooms more. The new camera system has been amazing. It's fascinating to watch, and we think it's going to be a really helpful tool in understanding cyanobacterial scum formation.
Data from the buoys is transmitted every 10 minutes to the cloud, where it can be viewed on WQ Data Live. With real-time monitoring systems in place, resource managers can better understand conditions, and water treatment operators can better respond to them. recreational users are also able to freely access the data.
There's a million uses for the data, and the most critical is that streaming data to support water treatment. But the data also have tremendous use in understanding shallow lake ecology and supporting different projects of the Global Lakes Ecological Observatory Network, or GLION. The data are streamed directly to water treatment plant operators so they can understand the changes in the lake conditions and adapt in real time. And that high-frequency data is really critical because the blooms can set up in hours or days. So often we can anticipate that bloom development using sensor data. In terms of insights from the data, some key eureka moments have come from talking with the plant about the data and issues they were having. For example, our science team and the water treatment plant all gained new insights about buoyant cyanobacteria, how they can impact water treatment, and how dynamic they are in this ecosystem. And that came out of group conversations and being able to dive into the sensor data, the plant data, and our own sampling.
As climate change and other human pressures force a re-examination of water security and resilience, data from monitoring systems, including the Buffalo Pound Lake buoys, are becoming increasingly important.
On the whole, the system we have is a really nice balance of, helping inform that science and what's critical operationally to understand bloom dynamics and shallow bloom-affected lakes. It's a really interesting lake and a really rich data set we've been building.
These observations help scientists deepen their understanding of water resources, while also supporting industry in delivering a clean, safe, and reliable water supply. Visit nexens.com for more information. Nexens. Better data. It's never been easier.